Now, whilst it's very easy to predict how big waves are going to be in the offshore, when they start to move towards the coastline, all sorts of things happen to them. They start to interact with the bathymetry, coastal reefs and headlands. We get processes like shoaling and refraction can also go over the dunes and inundate all the communities behind. So the first thing we're going to do, we're going to send our 5 waves down. We're going to have a look what happens. And what we saw is that even though the waves were breaking, there was still enough energy for them to roll up over the dunes, in this case fill up our reservoir. But in real life that would have meant that any houses or properties or communities behind the defence would have been completely flooded. And really that isn't an acceptable situation for us, so this is around the time where we bring in our coastal engineers. Alright, now we've just reset our tank and now we can start testing. Look how much we've actually got. Now what we've got here, we'll call that about 50 mil. And while it's only a little amount in our physical tank, this could easily be say 50 litres per second in real life. This is the sort of volume that will start leading to some problems. But still, it's better than if there was nothing behind there at all. And what we want to do now is see if we can try and improve the situation even more. So now we're ready to start designing some of our defences for this situation. Now the next defence we're going to check and test is our sloped revetment. Now this is about a 1 in 2, also known as a dike. And what we're going to do is we're going to put it in front of our defence. Now the argument is that we're going to now induce more braking against it. The waves are then going to be smaller when they hit our defence and it's going to have a better performance. Right, now we'll run our 5 waves through the tank. And what we've actually seen there is by putting the slope in front of the structure, we've actually made the overtopping worse. Where we thought the waves would break and dissipate their energy, they're actually hitting the structure, breaking right on it, and using it as a ramp to get over the defence itself. Now we'll just see how much water that we've got. Now what we've got is a completely full beaker, so we've made it consistently worse. Now we'll get that one back. Now this is one of the common myths that we see, that people think putting small slopes in front of a vertical wall is going to improve the situation. And what we find is about a 1 in 2, 1 in 1.5 is one of the worst conditions that we can get in relation to overtopping. Now there are a few ways that we can improve this coastal defence without changing any of the sediment properties or the slope in front of it. And the best way is to use a recurve wall. Now the beauty of this is it's not any higher or larger in the structure, but it's got this unique shape. Now this unique shape allows the water to come up, actually get captured in here and then shot back out to sea. And because of the nature of this, there's going to be less waves coming over the defence. Now we can show this by simply removing our vertical wall and clipping in our recurve. Now what we're going to do now is run our 5 waves again and see if there's any difference. And this time, what we've seen is the waves are actually getting shot back out to sea. There's probably the same amount of wave energy going up, but it's all returning out. So in terms of our safety and the inundation behind the defences, it's a lot better. And in fact, there was no water that actually came over at all. So something as simple as a recurve wall is a great way, a very cost-efficient way to improve a coastal flooding situation. Now the next defence we're going to be testing is our stepped revetment. Now this is at the same slope as our other revetment, except the only difference is this is essentially, it's got steps. We're going to see if these steps are going to change the performance of the defence. I've got that locked in, and we'll run our 5 waves. Now, there was still a lot of overtopping, and that's because we've still got that same gradient, that same slope that's letting the waves run up and hit the structure with a little bit more power. So this time, we see that we've got about 100 mils that's come over. So it's actually less than the sloped revetment, but still, it's not as good as the recurved wall. But now we're going to have a look if there's any other options that we can do. Now our last defence we're going to test today is our rock armour. This is all scaled down to fit into our model, but essentially it's representing a rubble mound structure that can go in place of the vertical structures altogether. Now we'll put it in our tank. Now we're going to run our 5 waves. And what we've found is actually the rock armour is a really good defence. It allows the wave energy to be absorbed. When the waves come up, they'll hit a rock, they'll go left, right, up, down, they'll hit another rock, they'll have to squeeze through gaps and change direction. And all the time they're really dissipating their energy. And when we have a look at the performance, we can see we've got very little, maybe about 5 mil. Rock armour is really effective. Now it's also cheap, but it has its drawbacks. You know, it covers up the beach, we get oyster growth, so it's always not the best option. So out of all of these, we've tested the rock armour, the stepped revetment, the sloped revetment and the recurve wall. We've found that all of these will have different performances. They can be